Good morning, mathematicians. It's a new day for math. And other things, I guess. Maybe it's a day for paintball. Not for me, but it was yesterday. There we go. That took a few seconds to get going. Hello, Matthias.
Maybe it's a day for paintball.
Good morning, good morning.
Not for me, but it was yesterday.
Put that here, put this here.
There we go.
Hope you're doing well. Yeah, I have no idea what I want to talk about today. The proof of Bernoulli's inequality. Maybe. So what's the actual equality? I see. 1 plus x to the r is greater than or equal to... Let's see. One plus x to the r is greater than or equal to 1 plus rx. One plus rx. Good question, Daysen. Let me make a note. We'll talk about local rings. Remind me if I forget. We'll talk about local rings after this Bernoulli question. For every real number... Oh, there's like two cases. Okay. For every real number outside of there... And this is less than or equal to 1 plus rx if r is inside there. Oh, and x is... Oh, r is bigger than 1, x is less than -1. Zero and 1. Hello, Ibrahim. I'll be honest, I don't love this question. Okay. Well, okay, here I think here's a general strategy if you want to prove something for real numbers. Here's what you can sometimes do. First, prove it for an integer. Then... Oh, you don't have... Yeah, don't worry about asking such simple questions. We can talk about simple questions on this channel. It's just, for whatever reason, people have their own personal tastes or preferences in mathematics. And this just isn't to my preference, is all. Prove it for integers, then prove it for rational numbers, and then prove it for real numbers. And the way that this can make it easier is, well, you might need to do 2 induction arguments if you're going to do the integers as opposed to naturals. But here you could do something like, probably this is a problem, either induction or, you could definitely, this screams binomial theorem, right? Then for the rational numbers, for the rational numbers, normally it is something like, you have it for the integers, which is, say, an easier proof by the previous step. And then, really, to get the rational numbers, somehow, so you just use terms of the form 1 over n, and then combine that with these previous cases. That might be a little more difficult here. And then the way that you do it for the real numbers, once you have that, is you can use things like supremums and infimums, right? Like, for instance, like like, how do you even define, if a is a real number, how do you actually define what x to the a even means? What does x to the a mean? Well, it is really defined to be the supremum of x to the r as r goes over the rational numbers. And what was I going to say? Sorry, I'm blanking. It's early. You tried the method of induction but ran into a wall. Okay, so let's try induction together. Anyways, this is a supremum where x ranges over all of over the rational numbers. And then in turn, maybe you've seen this, I don't know, how you slowly build up the definition of exponentiation. Do I know about the 3264 problem? I do, of course. Of course, there's a famous book with that name, 3264 and all that. Is it okay if you talk about homological algebra? I suppose, but you as in you have questions about it? What type of coffee am I sipping on? It is a coffee company. I think it's Black Bear or something. And it's from BC, and there it's a organic coffee company. Yeah. Perhaps soups over are less than a. Yeah. Definitely that's. Oh, sorry. Yes, you're right. Sorry. Yeah, R less than A. Yes, of course. Yeah, that's true. Just talking about exact sequences and ext. Well, I don't know. Sure, you can. You can talk about whatever in chat. Well, actually, I shouldn't say that. You can't talk about whatever. Certain things, obviously, in chat can't be discussed. But you can say stuff. But again, I will just remind you that if you don't really understand these things and you don't know how to do formal, rigorous proofs with them, that will probably become apparent to people, and people probably won't enjoy it. But you can say whatever, I guess. Okay, so let's look at the base case. So we'll do induction on n. Induction, or I mean binomial theorem. We might even just do binomial theorem, right? 1 plus rx, and here, oh, this is bigger than, yeah, and r is bigger than 1, and x is less than or equal to minus 1. Okay. Let's just look at this case. So, well, in the case of, so if n is equal to 1, this is what we're trying to prove. Right? But of course, r is negative, or sorry, x is negative, r is positive. So definitely x is going to be larger than rx, right? You've just taken a negative number, you've multiplied it by a larger positive number. This is going to be more negative, and you add 1 to both sides of the equation. So definitely holds. Now, actually, yeah, is induction the good thing to do here? Because it's not so clear that if we keep multiplying, well, certainly for the even powers, it'll be true, right? Because definitely any even power is going to be bigger than, but does it have to be bigger than 0? Yeah, it'll be bigger than 0, and this thing is less than or equal to 0. Paul Maurice, I said I knew about the 3264 problem. I didn't say that that I can use the machinery well and competently. Can I prove the degree of a hypersurface cut out by conics tangent to 5 conics? 5 given conics is 6. No, I can't. Not off the top of my head. Maybe this is one to put in the notes. I could maybe do some we could do some intersection theory in the future. But off the top of my head, no. I did once like take a course where I used that book, and I did some computations of, intersecting varieties and Grassmannians and stuff. So maybe if you'd asked me that question at the height of me taking that course. Okay, so what about for the odd numbers? Well, let's say we have it for an even number. And I guess we could just try multiplying both sides. Somehow I feel like this isn't going to work, though. Say multiply both sides. R plus x plus r squared x plus rx squared. In my math education, have I ever had something realized by me alone from learning topics, but eventually figured out that it's well known? Yes. Yes, yes, yes. I mean, this has happened actually a few times. Uh, um, this has happened a few times. Um, Probably the most memorable. I always meant to like write down the details before I forgot the story of how I came up with it, and I just never got around to it, and it floated into the past. Um, but the of particular note, I remember, and actually it had a good friend of mine was also invented some weird function, some funny function, and somehow this was related to that. And I did some. I don't. It started off as a very unrelated kind of thing. I don't even remember how it started off exactly, but it ended up in noticing a certain pattern in the Fibonacci numbers, um, and it was basically these certain like recurrence relations or something that they satisfy mod 6. And yeah, I basically rediscovered these recurrence relations, and turns out they already had a name. Someone beat me to it 100 years ago. But it felt cool. Felt cool to redrive those, even though like it's very basic kind of math. But um, yeah. I probably should, Paul. I probably should get good on my intersection theory stuff again, because I think I could use it for my some of my work to do some cohomology calculations. If I assume the Hodge conjecture. Um, in fact, we already did. There was actually also an undergrad project I helped lead where I got them to do some intersection theory computations, because they're relevant to some of the research my group does. Okay, let's see. Um, well, this term will be less than or equal. The r is less than or equal to 1. So we do get something like this. No, but I mean, I would expect this. Oh, yeah, I think 1 plus rx should be. So the goal then would be to prove that this. Let's see if we can work backwards from our goal. Our goal would be to prove this, right? So we definitely have this part of the inequality. We definitely have this part of the inequality here. And in fact, I mean, the thing is, this term is positive, and it should be quite positive. So what do we have here? Like 1 plus r squared plus rx x, maybe? I don't know if factoring out's the right thing. Well, you say thanks now, but I feel like I'm about to give up because I just don't love this problem. But as you can see, the start of I won't reveal anything here, but it says here proof of integer exponent. I'm sure if you scroll down, it proves the rest of it on the Wikipedia page. So I would go through that. What do I think of using AI for studying? I think AI is very. It's come a long way. It is perhaps concerning how good some of the answers can be that it gives to like even advanced undergraduate proof course type problems. But that is also like things that I'm filtering in hindsight. as someone with a bit more expertise and years of experience. So I would be very skeptical of using it. Still, I would be skeptical of the, because even if you're like, oh, can you try and break down this concept for me? It could be great because it could, query the internet and bring you a bunch of some good posts. But how do you know it's not? There's a lot of people on the internet that like to say things about stuff they don't actually understand. So how do you know that the AI isn't just like synthesizing a bunch of those responses as well? I mean, in fact, it definitively is. So, and then also like yesterday on stream, we had this question about proving this thing, and the AI. I mean, I should have noticed it, but the AI forgot this, which is some small technical detail. Arguably not a big deal, but I mean, this is math. Precision is a very big deal, and of course, textbooks can have typos as well, but they've been at least vetted by a human once or twice. So, yeah, asking Magic 8 Ball to do your taxes. I don't know if it's that. That's maybe a little hyperbolic. I do think there is the capacity for AI to be helpful, but I think it's a delicate thing. In fact, okay, so actually, let me say, I was actually part of I wasn't part of it, but I TA'd an algebra course this last semester where students participated in an AI experiment where some of them were allowed to use a certain like curated AI. And what's interesting is there's a bunch of students that I'm pretty sure cheated and just copied and pasted from AI. And apparently those students to clarify, students were participating in the study. They were allowed to query the AI to help them, but they were, told you can't just copy paste things from AI. Can I do things like toric geometry context where things are presumably simple to calculate? No, sorry. I'm sorry, Paul. You always ask good questions that I just can't answer. But yeah, so anyways, with the AI, so students were allowed to query it, but they weren't allowed to just copy paste the answer. And then there's a bunch of people I accused of copying, pasting the answer. Well, accused. It's obvious that they did. But what's interesting is that there was almost no overlap between the people, which suggests that actually if the students, because the students who participated in the study, they both had proper training on how to use an AI and what makes like for good use and bad use, and they had constant reminders for stuff, for what they are and aren't supposed to do. And well, I don't think the results are back yet about what the impact was on their learning outcomes, in whatever way we can actually measure that. But the point being is that, with some training, the AI could possibly be useful. Yeah, a student who struggles with math problems and tries to solve it versus who after a little struggle used AI to get the answers. Don't use AI to get the answers. I wouldn't use AI to get the answers. Just look up go to Stack Exchange. Go to Stack Exchange or something. Like you should work hard at trying to, prove a theorem yourself, work through it yourself. If you get stuck, go to Stack Exchange, or there's like Discord servers out there with, a bunch of math subjects and stuff. It's just better. You're just better off going and talking to people, because who knows what small bits of AI hallucination, right? If you're just learning a subject, it'll be very non-obvious to you, and those little bits will like percolate through, and that could ultimately slow down your progress. So yeah, I don't know. I think that there's you can maybe use it to try and like get an idea or something, um, to get hints or something, and then make do your due diligence at fact checking the things that it gives you. Because for instance, there was like, yeah, I don't know. There's certain problems that I saw people that were like obviously copying and pasting from, and it's like I could just tell right away. I'm like, that is not a human mistake, right? But I look at it, I know how the AI, okay, I know technically no one knows how the AI works officially, but you have a rough idea, right? And you look at that and you're like, oh, I understand exactly why the AI thought this. I understand exactly the word association it used to get here. Makes total sense. Not believable. That a human would make such a mistake, though. Matthias has used AI in the self-study of analysis. It's really hard not to have any class or professor to lean yourself up against. Yeah, that's fair, and I'm not saying don't use it at all, but I would lean on the online mathematics community of humans. That would be my recommendation. I'm not saying to not use it at all, but I think it's probably better that you interact with humans more so on these points. Your professor said next semester he's going to provide AI answers on the test, and the students will have to detect the mistake or interpret what it's saying. That's awesome, actually. Yeah, I mean, I was just talking yesterday with some people. But one of the things that I really like that my one of the professors here does is he hasn't done that with AI, but that's good. I got to tell him about that actually. But he'll put like an intro to proofs class. He'll put a proof that's deliberately wrong, or one that's right, and he'll say, "Hey, is there a flaw in this proof? Um, if there is, find it. Tell me what it is. Why is that a mistake?" Which is, I think, is a great learning tool. So I think that's an awesome idea. AI definitely gives wrong answers, yeah. Used it to solve atal cohomology problems, and it always gives wrong answers, even though it boasted quite heavy machinery before solving. Yeah, I mean, I definitely wouldn't use it for, say, a computational problem. Like, I definitely wouldn't say, oh, can you tell me the atal cohomology of this scheme? Unless maybe it's like a very basic example that's like a very common example, but even then, so then it's like, okay, well, if it's that common of an example, it's probably very easy for you to find like a blog post about computing it, right? So yeah, I don't think that's where it is very useful. I think it can be good for proofs and proof ideas, because a lot of proofs can be very wordy, right? And so it makes sense that a large language model will be able to cobble together the right assortment of words. Absolutely, but yeah, I would not ask it to compute things for me. Well, I'm yapping. Yeah, local rings. Yeah. Well, am I officially giving up on Matthias's question? Uh, I might. We did the even case, right? That's half of all integers. That's good enough, right? Um, yeah. I wonder. Let me see. Well, I wonder, can we take um yeah. Yeah, I don't know. Uh well, I don't know if it'd get things wrong if you asked it to prove stuff about cohomology. I think it could probably give you correct proofs. I believe it. You notice that AI can explain a lot of things really well. Yes, but here's the problem. How do you know it's explaining it correctly? You say it can explain it really well, and you go, oh, wow, I never understood that thing about cohomology before. How do you know you're getting the correct thing? Now, I would sooner trust its explanation than I would its computation, to be clear. Because, again, it's scraping the web for other people's explanations. Totally believable that it's, mashed the right words together from that. You use it to ask about things the book does not describe or explain well or skip over and gets you stuck. Yeah, but you know what? You can also ask those things. You can go to Stack Exchange and you can just use ordinary Google. And I guarantee you those other things, a lot of those other things will be written by humans somewhere. Yeah, I mean, that makes sense. Given some right answers for ordinary cohomology in Z, yeah, because probably there's like just a ton of documents on the internet that have, correctly computed those things. So that, I mean, it makes sense in that case. Okay, let me say something about local rings. Well, what was the exact question actually? Let me go all the way up. What's the importance of local rings going beyond ring theory? Well, I mean, immediately one wants to launch into a discussion about algebraic geometry, but I mean, technically, local rings are about ring theory inherently, so. I mean, maybe it's worth just explaining the name. That the thing is, the point is in algebraic geometry. Say, for instance, your structure sheaf, the stock of this is a local ring. In fact, this is another case where I think at first it's like, well, this is basically by definition. You define these things to be local rings. But I think the intuition of why this should be the case, either, I would look at manifolds and the sheaf of smooth functions, or even just think about like the classical case, say like, affine space. I guess we could call it spec if we wanted. Over an algebraically closed field. With our ring of functions, or sheaf, if you will. Right? Because why is this? This is basically this will always be a local ring, right? So what is the if we take I don't call it O for the sheaf, the stock at any point is exactly going to be given by the ratios of polynomials where G doesn't vanish at that point. And it will always have a maximal ideal given by those functions generated by those functions where f does vanish at the point. And this statement is true also in differential geometry as well. So that is, I guess, kind of the immediate importance of local. In fact, I mean, this is why a local ring is called a local ring, because you've localized your sheaf. You're looking at the functions locally defined in these neighborhoods. And it turns out that your stock of your sheaf is an example of a local ring. So, which is to say, the stock of your sheaf has a unique maximal ideal. And in fact, so that is why we say a ring is local if it has a unique maximal ideal. It is given Nicholas mostly correct answers for sheaf cohomology of schemes. That's interesting. For like proofs or for computations? You never ask anything that's beyond your limits of understanding. If you can't comprehend the topic, you won't attempt to understand it from ChatGPT. Well, that's good. In your limited experience, it just has no real ability to reason. Yes, that's true. To make non-trivial arguments and deductions, or to correct itself once you point out the obvious mistakes. Yeah, that is true. That is true. All it can do is collect information from other people. If Springer or other editors were more accessible, AI would be better. I don't know. Maybe. This could be misinformation, so maybe I should stop repeating it, at least until I do some research and find out where this has been said somewhere else. But I did hear once, I've said this before on office hours, but I did hear once from someone that if you models that are trained on to understand multiple languages tend to fare better on math, which I don't know. Again, this is a rumor, but so that's an interesting thing. An even simpler thing that got you thinking and got you stuck in the textbook says, now pick a natural number n. Right. Hang on 1 second, gang. Okay. Yeah, so this is just a use of the Archimedean property, right? So the Archimedean property says what? I guess it says if I guess one way to phrase it is if x is a real number which is greater than 0, then there exists an n in here such that xn is bigger, or I guess we could say xy. Say an integer. I don't know. There's different ways to phrase it. There's different ways to phrase it, but yeah, that's the basic idea, right? So here we have m bigger than 0, and we have b equal to a minus 1, and we have the assumption, and then this is bigger than 0, because there's an assumption, hello Julie, that a is bigger than 0, right? So m minus 1, oh, should there maybe be another assumption on m? Oh no, that's fine, right? So m minus 1 over b. Actually, I mean, we don't even need. Actually, looking closer at this now, I mean, of course, there is such a thing. I mean, you just take the ceiling function, right? You just take the ceiling function. I mean, technically, you need the Archimedean property to define the ceiling function. So I'm kind of kicking the can down the road here. So I don't know where you are in the textbook. Maybe it wants you to argue it more formally. But yeah. So certainly this is possible. I guess if you wanted to do it more formally with the Archimedean property, you would say something like, well, let's see. Let's see what how Wikipedia phrases the Archimedean property. Notice how I skipped past the AI answer. Given two positive integers. Okay, it just says two positive integers, right? So yeah. So you could say it like that. There's two cases, right? Because there isn't a restriction on m, right? So we know that b is positive. So if m wait, does m have to be a natural number? I don't think so, right? So if m is less than 1, right, and we know it's also bigger than 0, then, you know, m minus 1 is negative, and that implies that m minus 1 over b is negative. Hence, you know, 1 is a natural number, and 1 is certainly larger than 0, which is larger than m minus 1 over b. Right? Now, if m minus 1, or rather, I suppose we could make this less than or equal, actually. Make this less than or equal. So now we could say if m is, so maybe I'll make this less than or equal. So we could say if m is strictly bigger than 1, then m minus 1 is bigger than 0, which implies that m minus 1 over b is strictly bigger than 0. So now, by the way that the Archimedean property is phrased, since m minus 1 over b and 1 are both positive, by the Archimedean property, we can choose an n in the natural numbers such that n times 1 is bigger than or equal to this. Or we could even take strict. No, I have no idea about Stanley-Reisner rings. I do not. Yeah. There were some other questions from a long time ago, right? Oh, intersection theory. I just put a general note about intersection theory. Yeah, I don't know. Yeah. Well, I guess let's look up Stanley-Reisner rings. Why not? Quotient of a polynomial. Oh, you know what? Actually, I do remember. Actually, maybe I've seen these before. I think there was an undergrad here who sent me their slides and was asking for feedback on their slide presentation. Yeah, well, this is part of the process, Matthias. Getting stuck on random stuff. That's part of the process. Yeah, I think I have seen this, but I've never, like, I don't know much about the theory at all. But I have at least, I have encountered this definition once before. I think I might call it there for today. Shorter stream, later start. What can you do? It do be like that. I gotta go get some work done. Time to prove things. You know how it is. QED.